think I would have been like more hated.
Depends.
I would have more loved you and I would have been like that. I would have thought it was good.
Make sure you.
I was upset about it. You said it was good.
I'm sorry. I just was trying to make you feel better.
Yeah, I was like, yeah, this rumor's going around. Brooke's like, that's dope. I was like, no.
Sorry. I didn't know what to say.
Is the camera on?
Yeah.
It's not true. It's not true.
I don't think you heard the rumor because I didn't hear the rumor.
Okay.
This is what you want to know.
This
This.
went over your goal.
I do hear quite a bit of things that I don't always want to know about.
So, do you want to hear the rumor?
Not at the moment, after the lesson. Alright, so the parameter that we're interested in is figuring out the true proportions of free throws that Allie has made Mason.
What?
Our statistic is the 33 out of 50 that Allie made, so 0.66. Allie's claim is that she's an 80% free throw shooter. Disclaimer, she says that I'm lying. But for the sake of my lesson, I'm going to say Allie says she claims to be an 80% free throw shooter. And then the AP Stats class's claim is she's not really that good. Sorry, Allie. Alright, so we are starting a new unit. We're going to be looking at significance tests. Ugh, that orange looks hideous under this new camera. It is really bright. So, your work day, it kind of looks like there are two separate work days, but I couldn't get them on the same day for both periods. So your work day is on March 13th. And then this is period 3's work day.
What's the unit 6 and 7 retake deadline by chance?
It was
A while ago. You can still retake them.
Oh.
You just can only get a seat.
Did you not
Then
know
you
that?
gotta take them.
Are you kidding me?
Colton,
No, we've been to.
You-
I was chill with the 79.
you guys were content.
you
Because
were
you can get a 79.
in my class last year, and that was my rule last year.
No, I knew
too.
there was a rule. I just didn't know when.
Cool, it's been like a month.
All right. So,
I knew that I would have got that long.
do we have good evidence against Allie's claim?
Yes.
Oh, I heard a yes and a no. We're gonna learn how to actually answer that question today.
This apple's.
So, we're getting into significance testing, so today is going to be a lot of words so that I can get the main ideas out there. So, a significance test, Brooke, is a formal procedure for comparing observed data with a claim. So, we're going to compare Allie's claim that she's a 80% free throw shooter with some data. And then we're gonna run a test on it. A claim tested by a significance test is called the null hypothesis.
What?
Null hypothesis?
Null hypothesis. And we use H with a subscript of an O. I think in science they would say not for that subscript, not null. Ho, ho, it's a ho. H-O, ho. Like Santa, ho, ho, ho.
Or just.
But I was trying to be appropriate.
Oh, sorry.
The test is designed to assess the strength of the evidence against the null hypothesis. And a lot of times the null hypothesis is a statement of no difference. The claim about the population that we're trying to find evidence for is called the alternative hypothesis. Alternative. And we use H with a little a for the subscript. So we have ho and ha. The alternative hypothesis should always be created before you see the data. But as I've taught you many times, well, I hope you've been listening, that in statistics they often do things to make it say a certain thing. So even though we should create our alternative before seeing the data, that doesn't always happen, so that, they can mislead you with information. The alternative hypothesis is one-sided if it states that a parameter is greater than the null hypothesis, or if it states that the parameter is less than the null hypothesis. So if we have alligators in our alternative, then it's a one-sided test. It would be two-sided if it states that the parameter is different from or not equal to. And that means that our alternative could be either larger or smaller than the claim. Or, I forgot the word not, sorry, not equal to. Both the null and alternative hypothesis refer to a population and not a sample. So are we going to use parameters or statistics when we write these? For referring to the population, we should use a parameter. All right, so down below, we're going to describe our parameter of interest, which means we're going to have a semi-sentence. It's not going to be a perfect sentence. And then we're going to state some hypotheses. So the first one says, according to the website sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks an SRS of 100 students at the school how much sleep they get on a typical night. In all, 75 of the responders said less than 8 hours. So, A, we're just going to describe what we're interested in. So she's looking at the true proportion of teens who get less than 8 hours of sleep. And I'm going to abbreviate proportion. And then B, we're going to state a null hypothesis and an alternative hypothesis. So what is the claim? What percent of teens
85%
are getting less than 8 hours? So here's our claim.
This is the null.
This is the null. And we use a parameter. We're working with proportions, so our parameter is P. So the null hypothesis is that P equals 0.85. Now, our alternative, do we think greater than, less than, not equal to? Why did you say less than?
Because it's 75%.
Okay, but we should create our alternative before we know our sample.
Because we have a smaller sample size than...
There is a sentence in here that should lead you to an alternative. What does Janie wonder?
Whether the result holds in her large high school.
So she say greater than, less than, or just she's curious if it holds true?
I think if it holds true, so equal.
So that would mean our alternative is that it's different from this. She's not specifying whether it's less than or greater than. So we would say our alternative is that P does not equal 0.85.
So if it doesn't clearly state, then we just assume it's
Different.
And this would be a alternative hypothesis that would make us do a two-sided test. If it was strictly greater than, less than, then it'd be one-sided.
Phone call.
Answer. Look, can I answer?
Banana phone.
No.
Why can't I answer?
Ba, 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 ba.
Hello? I don't think so. I didn't call anybody. Sorry. Alright,
What happened?
you got a missed call from my number? I don't know. Some guy. I didn't call anybody. Alright, try number 2. State the parameter of interest and then come up with your null and alternative hypothesis, please.
No.
Wait, what's the two-sided test? Do we have to do that or you just say that?
We will eventually
How
learn
about
how
right
to do it. Right now, no. Today we're going to focus on one-sided tests. But right now I just want you to practice writing the parameter and then your hypotheses. Average length of time.
Wait, what would be about? Like, for A, true households who take the census at 10.
We're looking at the average length of time it takes. That average household will take 10 minutes. So that means the average is 7 minutes.
Oh, I don't know.
The next part is our statistics.
Oh, it's Queen Street. Street Geometry. Page
Yeah.
Use
This is P.
It's just so fun.
Well, you go through the course. Not
Are you wearing CP?
yeah.
Because we showed me TV.
So embarrassing.
Why is it embarrassing to show school?
I'm doing it too. I wore red and black.
Well, but it's just going in. You think
All right, Allie's gonna put the answers up there for you.
Yeah, that's what I'm feeling this year.
Are you good?
I don't know.
Yes, we're
Do it.
working on average.
I'm doing it. Do it.
I know. I can't. You guys don't know what it really does to me. Like, oh my god,
You're
my
like,
hair.
why is she so weird?
No. That was not real.
You look like a character from
That's a little weird. I have
Please take-
purpose behind
You look like you resigned as
Because my hair is gross right now. Because I can't wash my hair
Not
tomorrow.
Why?
Because Jazz
Not
is making me
these,
wash
it's
my hair
X-Mars?
3 times a week.
So is this a one-sided
Ashman.
Oh, it's the.
Yes.
Is it the leaves?
I don't wash my hair. I only wash it 3 times a week. I want 11 feet. I want
How
11 feet either.
So, do you wash your hair every other day or what? Like,
Yeah.
I wash my hair every day, other day.
I wash. Yeah. I sometimes I try.
But
to do
usually
days.
I used to wash it every day.
It's bad for your
I
hair.
know.
Do you
You never
condition
ever wash
it
your hair.
every day?
Is that why your clothes so nice? It's just the natural oils.
I always tell you my hair is the healthiest.
Thank you,
So
Allie.
do you just like rinse and like scrub?
Water.
All right. True average length of time it takes to complete the form is the parameter of interest. Our null hypothesis is that the average mu is 10 and that the alternative is it's greater than 10. Since we have greater than, this would be considered a one-sided test.
Why is it?
Because we're only looking at greater than 10. We're only looking at one side of 10. Up here, we're saying not equal to, so that could be a number bigger than 0.85 or a number less than. So there are two sides.
Okay.
All right, so everybody good if I flip?
Yes. Flip it.
All right, the probability computed assuming H null is true that the statistic such as p hat or x bar would take a value as extreme as or more extreme than the one actually observed is called the p-value of the test. Colton.
I don't have any gum, it's empty.
The smaller the p-value, the stronger the evidence against H null provided by the data.
Hey, dude.
You stop. If the p-value is smaller than alpha, alpha is the Greek letter that looks like the fish, but don't connect the tail.
Why?
Because then it's a fish and not alpha.
Does that mean it is?
It's just
It becomes a fish.
Is that like a, do we use that?
No. So if
It's
we'll,
Fish.
Well, yeah,
Fish and
we'll get there in a second. If our p-value is smaller than alpha, we say that the data are statistically significant. It should just like
Because I remember this from like a long time ago. Didn't we go over this before?
yeah, we did talk about statistically significant very broadly.
Now we have to actually use it?
Yeah.
Real.
And we would say it's statistically significant at level alpha.
I don't trust it, but I
Oh man, I don't like this new projector as much. If our p-value is less than alpha, we have statistically significant data, and in that case we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative hypothesis. Well, I don't know how to spell alternative hypothesis.
Cody's.
So, Brooke asked a great question. She said, what is alpha? Alpha is usually 0.05, unless otherwise specified.
why?
Because.
Well, when we find our p-value, we're going to find the area under the curve. And so we're finding the probability that our result happens 5% of the time or less. And so we would say that's statistically significant. So if it doesn't specify an alpha, you use 0.05. If it wants you to use something else, it's going to specify. You can get as low as 0.01. You can go as high as 0.1. But this is the most common alpha level. So when we compare the p-value to alpha, there are two results. The first result is that the p-value is less than alpha, in which case we reject the null hypothesis. So, the other possibility is if our p-value is greater than or equal to alpha, in which case we would fail to reject H null.
Fail to reject? So we. What, if we reject it, do we just stop there? Stop. Don't touch me there. That is my notice square.
Oh,
that what we do?
No, please do not do that.
So it's rejected. So that's when we go with alternative?
Yeah. Well, if we reject H null, we go with the alternative.
Which is what
And then if we fail to reject, we go with the null.
Yes, but we can't word it that way. I'm gonna tell you how to word it down here.
Oh.
This is the one thing about this. Kids always are like, why do it's a very, in my opinion, a very negative way of wording these things. But this is how they word it. I didn't come up with this. I just followed the rules. So if our p-value is less than alpha, that tells us, excuse me, that we have strong evidence against H null.
That's why I know no square right here.
I'm just gonna remind you that I am recording. So if we have strong evidence against H null, we're gonna reject the null hypothesis. And if we reject the null hypothesis, then we're gonna conclude that the alternative is true.
Which is what we. Never mind.
I'm gonna zoom in a little. See if
Or went into this one.
Is that HA?
HA, sorry, but it is a bad A.
That's it, Jay?
That's HA at the end. It's a bad HA. Now, if our p-value is greater than or equal to alpha, that tells us we have weak evidence against H null.
That's huge. No, I'm being dead serious. I'm being dead serious. That's.
Shh, please stop. Please stop. And if we have weak evidence against H null, we're going to fail to reject H null, which, by the way, shows up a lot. So you might see FTR, fail to reject. So we would fail to reject H null. And if we don't reject H null, then we cannot conclude the alternative.
Wait, no. It's about 6
So notice
Maybe.
when we talk about rejecting or failing to reject, we reference the null hypothesis. We reject the null or we fail to reject the null. When we talk about concluding or not concluding, we reference the alternative. You can conclude the alternative or not. You don't ever reject or fail to reject the alternative. You don't ever conclude or not conclude the null. Rejecting is for the null. Concluding is for the alternative.
Boy, what?
So now we're going to go back to Allie and her free throw shooting.
Oh, Allie changed it.
We're going to have strong evidence against Allie.
Yeah, sorry, Allie.
Stop.
No way, you just.
All right, so just as a reminder, our parameter of interest is the true proportion of free throws that Allie has made. And I'm going to abbreviate free throws. Our statistic was that Allie went to the gym. She shot 50 free throws and she made 33 of them. So our p hat is 33 out of 50, or 0.66. Allie's claim is that she's an 80% free throw shooter. Claim. that tells us that's our null hypothesis. That P is 0.8. And then Dia put on the warm-up for us. The AP stats claim is she's really not that good. So that's our alternative, that P is less than 0.8.
Is that supposed to be an A, right?
HA? Yeah. And I told you we're going to learn how to answer, does the data provide good evidence against Allie's claim? And we're going to answer that by asking ourselves the question, if we assume Allie's claim is true, what's the probability that we get a P hat? Hey, you guys should be writing. A P hat equal to 0.66 or lower, purely by chance. And purely by chance also is going to become a very common phrase, so we're going to use PBC to abbreviate. PBC. So, how could we figure out the probability we get a 0.66 or lower purely by chance? You're ready to go take some shots?
Wait, is she
To the
supposed to
gym.
do it?
Wouldn't that be fun? I should get a fake one of those hoops that hangs over the back of my door so that we could actually. We're just gonna do it the boring math way and use the calculator.
Oh, yeah.
Oh, well, she could crumple up paper and shoot. See if she can make them. All right, so we're gonna do a simulation. Why? To figure out the probability that if she's an 80% free throw shooter.
When are we gonna apply this?
After our simulation. Because we got to get a p-value first.
Okay.
All right, so Allie's going to take 50 free throws. What's Allie's claim, Colton?
Allie's claim is that she shoots 80%, or P equals 1.
She shoots 80%. So on the calculator, like I said, it's a boring thing, but we can pick random integers, right? So we're going to do the random integer thingy-mabob. If we use the numbers 0 through 9, that's 10 digits, right?
Yes.
And we're going to have it pick 50 numbers for us to represent the 50 shots she takes. Yeah. So we need to specify what numbers means she makes the shot and misses the shot. So Allie, pick a number 0 through 9 to miss.
Yes.
Yes, it's gonna mean you miss.
8.
8. So an 8 means miss, and then let's see, Clara, pick another number not 8. 6. All right, so 8 and 6 means she misses, which means a make is 0, 1, 2, 3, 4, 5, 7, and 9.
Oh, I remember doing this.
Yeah, we have done this before, but not for missing and making shots. It was for Mountain Dew,
Yeah.
right?
Yeah.
Yeah. All right, so you're gonna get your calculator out. You're gonna pick. Well, it'll do 50 at once. Just don't scroll up because if you scroll up, then you can't look through the list.
Is
So
it
just
stat? Where is it?
under math,
Oh, okay.
go to prob.
Oh my goodness.
I'll do it too.
So many numbers.
It's going to give you 50 numbers. It's probably going to be easier to count the misses.
Do I count the misses?
Count
So
the
we don't
misses.
do anything like repeats or anything? We don't care about that?
How do you?
No.
Oh,
It's math, prob, ramp, int.
I got hell
Yes,
zero.
math, prob, and then number 5.
Oh, you
0,
missed the first one.
9, and then we went 50. If you have the older calculator, just put commas in between. And then the biggest thing, like I said, once it gives you the list, don't scroll up and highlight the list, because if you do that, then you can't actually look through the list.
So we're writing all this down?
No, you don't have to write them down. Just figure out how many you missed, so we know how many you made.
I'm only getting 3, 6, 8, and 0. I haven't gotten anything else.
That's weird.
How do I look through it?
Do I just go over?
There's a 7, and a 5, and a 4.
1.
That is odd,
Did you go up?
Yeah.
Maybe.
So, did you go up? Don't go up.
Okay, got it, got it. There's a lot of misses.
So just like tally mark on whichever.
I'm just gonna
Or
count.
just count.
5. 5 misses.
So, I got that Allie missed 8 times. So that means she made 42 of them.
Damn.
And 42 out of 50 turns into 0.84. So you may have the same p-hat as me, but you probably have a different one. And then we're going to make a graph down here.
You did worse than the first one. For this one, I don't know. I think it's
42.
I did 92% of this one, so 64.
Alright, so we're going to make a class sampling distribution for our p-hat. So I'm going to ask each and every one of you what you got for Allie's p-hat. And we're going to make a dot plot. We're going to go 0.5 to 1. So that means 0.6, 0.7, 0.8, 0.9. And then we can put 4 hash marks in between for the 2, 4, 6, 8s. .6, 0.7, 0.8, and 0.9. So I got 0.84, so I'll put my dot above that. Alright. Colton, what was your p-hat?
Skip me.
Okay. Megan, do you have your p-hat?
Yeah, 0.68.
0.68. Alright. DJ?
0.74.
Mason?
9-4.
0.94.
Yeah.
Good job, Allie.
What can I say?
Clara?
0.68.
Allie?
0.92.
Good job, Allie. Yeah?
0.64.
Brooke?
0.85.
The 8? No. It's out of 50.
Okay, fine. Hold on.
Oh, how much did you
It was 45 out of 50, so it's 90. Whoops.
45 out of 50?
So it's 90. Whoops.
I feel like I'm being lied to.
Mine's 0.8.
0.8.
Okay,
Alright, Colton.
0.66.
Wow. You guys had to be the class that's going to break my lesson, aren't you? Well, what was the question we were trying to answer?
If it was less.
What's the probability we get a p-hat of 0.66 or lower purely by chance? Every time I've done this lesson, none. I get none. And I got 2. Dia and Colton. You guys had to ruin this for me, didn't you? So 0.66 or lower. 0.66 is here. So we have 2 pieces of data out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which would be what? 0.2, right? So is it really that unusual for Allie to only make 33 out of 50? No. It happens 20% of the time purely by chance. This would be what we consider our p-value. Alpha, we would use 0.05. And in this case, the p-value is not less than alpha. So we have weak evidence against Allie's claim.
So we need one more.
So we would fail to reject Allie's claim and say that, that we can't conclude she really isn't an 80% free throw shooter.
Okay, so I am.
Yesterday, I got to keep saying Allie's a liar, but you guys had to ruin that. I wanted to pick on her. Actually, no, I'm going to make you a liar. Sorry, Allie. So, that's a simulation. Colton made a comment. He said, shouldn't we get more samples? Yeah, we should, but there's also something that we know how to find probability using, and that's the normal curve. Now, the question that we're trying to answer is assuming that Allie's claim is true, that she really is an 80% free throw shooter. That's why we made 8 numbers represent making. So when we do our normal curve, you always put the null hypothesis at the center. You make it your mean. Trey, stop distracting Maggie.
I'm sorry.
Now, anybody remember how to find standard deviation using proportions?
No, never.
P equals.
You should know this. I reminded you this yesterday. P hat
Times 1 minus
times 1 minus p hat
over n square root.
over n
How does she
square
just
root.
remember everything ever?
She's Jesus.
She's Dia.
It's just. That's true.
So we're gonna put 0.8 in because we're assuming the 0.8 is true. So 0.8 times 0.2 divided by 50 and then square rooted.
Yep.
So what is that? 0.8 times 0.2 divided by 50
Yeah. So we have
square
to do that.
rooted.
I agree.
And we get 0.056 for our standard deviation.
What did you do?
So then we're going to label our 3 standard deviations above and below.
I'm sorry.
So this is 0.856, so that'd be 0.912, and that'd be 0.968. 75, so that'd be 0.744. 569.688. 3.632. Alright, so we want to figure out the probability that we get a p-value of 0.66 or lower purely by chance.
I know.
So 0.66 is right here, Colton. And lower would be to the left, so we're going to find the area under the curve right there. So we're gonna do normal CDF. What's my lower bound, Brooke?
-1E 99.
Thank you, ma'am. What's my upper bound, Maggie?
Dude, Vanderbilt lost in Nebraska.
I don't know.
Vanderbilt.
0.2.
0.66.
0.66.
Thanks, Maggie. Because that's where I'm interested in. 0.66. My mean is 0.8. My standard deviation is 0.056. So then we put that in the calculator, and we're going to find the probability that Allie is an 80% free throw shooter and went to the gym and shot 66% purely by chance. And we get 0.0062. So, how likely is it that Allie shoots 66% if she's really an 80% free throw shooter?
Very, very, very unlikely.
Yeah, it's less than 1%. Sorry, Allie. Our simulation over here just wasn't good. So,
Which is less than 0.05.
it is less than alpha. So now we get to write our first conclusion. So remember with chapter 8, our conclusions were we are 95% confident, and it was a nice little simple sentence. Well, throw that out the door. This is a paragraph. So, we got a p-value of 0.007. We got 0.0062. That was because I've rounded differently on my standard deviation, but let's go with 0.0062. So, we always start these conclusions saying, assuming H null is true. Yes, I'm looking at you, Maggie.
What?
Assuming H null is true.
You almost ate it.
And in this case, our H null is that P equals 0.8. There is a 0.0062 probability. I'm going to abbreviate probability of getting a p hat less than or equal to 0.66 purely by chance. So like Brooke said, that's less than our alpha level, which tells us we have strong evidence. So this...
Why do we say strong evidence instead of statistically significant?
Oh, we're getting there.
Oh,
We say both.
Awesome.
This provides strong evidence against H null. And is statistically
significant.
Thank you. At alpha equals 0.05. Now, statistically significant is also something we're going to write a lot. So you'll see me put stat sig because I'm lazy and because I've run out of room sometimes. So I put statistically sig this time. At alpha equals 0.05. And we know that because our p-value is less than alpha. And when our p-value is less than alpha, we reject H null. Therefore, we reject H null. And we conclude the alternative. And when you conclude or not conclude the alternative, you need to put context. So I'm going to conclude the alternative if my pen will work, that the true proportion of free throws Allie makes, true proportion of free throws Allie makes is less than 0.8. Told you it was a paragraph. I know it's not English, I'm sorry.
You should get English credits. You know, it's like a joke.
I'm sorry. Alright, so that's a conclusion when your p-value is less than alpha. Now, had Allie made just 4 more free throws and made 37 out of 50, we would have gotten a p-value of 0.144, and our p-value would have been greater than alpha, and our whole conclusion would have changed. So we're going to write that conclusion just so,
There's no need.
just so
I
you
get it,
can
though.
see the
No,
difference.
But I get it though.
Can we do it tomorrow?
Good.
No. Because in your homework, you're going to have a conclusion, maybe, that the p-value is less than alpha, and you may have a conclusion in your homework where the p-value is greater than or equal to alpha, and therefore you need to see both. They are quite similar, but they are different. So I want you to have both of them.
Bet that, man.
Okay. All right, we start the same, assuming H null is true. That our p equals 0.8. There is a 0.144 probability of getting. Now our p hat is also going to change, because this time Allie made 37 out of 50. So our p hat would be what? That'd be 60 and 1474.74. 37 out of 50. It's 0.74. Less than or equal to 0.74 purely by chance. See, and that's where those nice little abbreviations come in handy. So if we have a probability of 0.144, that's bigger than alpha, so we would say this provides weak evidence against the null. And is not statistically significant. And I'm going to abbreviate that as stat sig at alpha equals 0.05. And that's because our p-value is greater than or equal to alpha. And if our p-value is greater than or equal to alpha, we failed to reject the null. Therefore, we failed to reject the null. And cannot conclude the alternative. And then again, add context. That the true proportion of free throws Allie makes is less than 0.8. Isn't it beautiful?
No.
Oh.
Is this gonna be our whole homework?
What?
Are we gonna have to do this for the whole homework?
I honestly don't remember how many of them have it. And I don't know. Oh, this is my book.
So what's the FTR?
Fail to reject.
Tired.
I don't remember what numbers I assigned either.
Then better have my money.
5 through 13 on.
1 through 13.
1 through 13 on.
But you want to
That's
check?
why he was like not counting the miles.
Good job.
Yeah. That's why he's giving.
One is just hypotheses, so it's 3 and 5. 7 is stating whether the hypotheses make sense. So is 9. 11 is got a conclusion. And 13. No.
So like 4.
1, 3, and 5. No. 1, 3, and 5 are like this.
Oh, okay.
Then 7 and 9 are just here's the situation, here's the hypotheses. Are they correct?
That's where they conclude.
No.
No. Then do we just say they're not correct?
Yeah, either they're correct for the situation or they're not. And then 11,
Okay.
you have to make a conclusion when it says interpret the p-value.
Okay.
And then 13 is also a conclusion. Yes, I'm sorry. So I wasn't that mean.
No.